Today, let's talk about something that's super important if you're working with welded parts. Hardness testing on welds. Sounds technical? It is, but I'll break it down in a simple way. Let's go. Welding is an important process in manufacturing, construction and engineering. Just think about steel construction in buildings or bridges or just the bodywork of vehicles. Welds can be found everywhere in your daily life. So, weldings must meet the high quality standards. First, let's understand the complexity of a weld. A weld isn't just one material. You've got the base metal, the weld metal and the heat affected zone. The heat affected zone is the area of the base material that's altered by the heat from the welding process. Each of these parts behaves differently, so we have to be precise about where and how we measure. The heat affected zone, in particular, often has properties that can vary significantly from the base metal or the weld metal, making it challenging to assess. Next up, there's hardening. When welding, the heat applied and the cooling rate can cause parts of the material to become much harder than desired. While hardness sounds good, too much can actually make the material brittle and prone to cracking. This is where controlling the cooling process becomes crucial. Finally, not all materials are the same. Whether you're working with stainless steel, aluminum or high-strength steel, each material behaves differently under heat and controlling. This requires different approaches for each material, and that's where standards and specific testing methods come in to guide us. When it comes to testing, there are additional hurdles. First, in order to accurately measure hardness in the different zones of the weld, we need to clearly identify them. This often requires etching in the sample, which can make the indents harder to see. And then, the indents must be placed according to the standardized patterns to ensure consistent and accurate results. The process of positioning the indents becomes particularly tricky because it requires precision, especially when dealing with different materials, behaviors and weld zones. This is where our welding model for HAZ 3 makes a big difference. It is designed to handle all the challenges mentioned above, making the positioning of indents much easier and more precise. It's flexible and adapts to all types of materials, cooling rates and weld zones. By streamlining the indent placement process, it reduces human error and ensures that the indents are positioned according to the required standards every time. Moreover, our welding model provides application-specific reports displaying the hardness values in relation to the specific weld zones. This makes it easier to interpret the test data so you can quickly assess whether the weld meets the required quality standards. So, the next time you're testing a weld, ask yourself, are you checking the right zones? Do you need to control the cooling better? Are your values within limits? Because in the end, a good weld isn't just strong, it's smartly made and tested.